Now that we feel a little bit more comfortable with equations, we want to step it up a notch and talk about inequalities. So if we have a statement that one quantity is more or less than another or equal, it's called an inequality. So I'm going to start with just some examples. 2 less than 5 means 2 is less than 5, which is something that is definitely a true statement. Okay. So really this symbol in between means less than. Right? If I have 1 with the symbol where it's pointing towards the 1 instead and then -4, this means 1 is greater than or equal to 4. Okay. So this symbol in between is standing for greater than or equal to. And we know this is also a true statement. Okay. So basically, if you have this bar underneath, it's indicating that you could equal as well. But if it's this, we call it a strict inequality, it means these two cannot equal each other. So one side has to be bigger than the other. So what we want to do is if I have a variable, we want to figure out what variables or what values can I plug in to make it a true statement. Now, unlike with equations, there's a lot more solutions to these. So if I have x is greater than 2, this means we can take all values of x that are greater than 2. So to just compare those symbols, this is indicating greater than. If you have the bar underneath, that means equal. So the symbol that's smaller or leaning towards the right is going to be less than. The way we typically learn about this is it kind of looks like a crocodile mouth when it opens. So the crocodile is always going to point towards the bigger thing because it wants more food. So in this case, it's pointing towards the 5 because that's bigger. In here, it's pointing towards +1 because we consider that bigger than a negative number. Okay. So in this last example, if I think about some values that solve this, 3 is definitely greater than 2. 4 is greater than 2. 7.5 is greater than 2. And in reality, you have a ton of options because 1,000,000 is greater than 2, 1,000,000.1, 1,000,000.2. You have way too many that you can possibly list out. So when we're looking for solutions to an inequality, it's going to be the set of all numbers that make the inequality true when it's substituted back into the variable. So here, all of these numbers, if I substitute it back in, lead me to a true statement, okay? So what we typically like to do is work with number lines for this. So let's try some examples where I'm gonna just go ahead and graph these on a number line so you can see the values that would make this work. So looking at this first one, I can take values of x that are less than or equal to 0. So if you think about plugging numbers in, if I tried to plug in 2, 2 is less than 0 or equal. That's definitely not a true statement. So that value doesn't work. If you tried to plug in +1, 1 is less than or equal to 0. Also does not work. If I try to plug in 0, 0 is less than or equal to 0. This actually is a true statement because of that bar underneath. 0 is less than or equal to 0. So this is actually going to be our pivotal number. So 0 is that key component where things are going to switch. And because I can actually equal it, it means we're going to be able to fill in this circle. So here we can equal this number. And that's because of the inequality symbol that we have, less than or equal to. Because 0 is less than or equal to 0 is a true statement. But now the values on this side are not going to work. Because if I try to plug any of them in, I get 2 is less than or equal to 0. Definitely not a true statement. However, if I pick anything over here, it is going to work for me. So to just kind of show you with an example, these values on the left-hand side work. Because -2 is definitely less than or equal to 0. I get something that is a true statement. And really it's because I can take all values of x that are less than or equal to 0. So anything less than or equal is going to be good. So this entire half of this inequality or this number line is going to work for us. So our solution is going to be this shaded region, including 0. Okay. Now, if I try this next one, though, I have this strict inequality. X has to be greater than 4. So I know 4 is a key component that's going to be my cutoff. And so I'm going to put a circle around it because it is important. But the problem is I can't equal this one, because I don't have that bar that's underneath it. Because if I tried to plug in 4, I get 4 is greater than 4. That is not a true statement here. Okay. But if I think of all the values of x that are bigger than 4, that's going to be numbers like 5, 6, 7, 8, 9, 10. Anything over here is going to work. Okay. So the values on this side work. And you can plug them in to verify that you do get a good statement. If I replace 5 by x, it works. Okay. But the values on this side don't. If you try to plug in 2, 2 is greater than 4 is not a true statement. Okay. So what we're going to be doing is we're going to try, if we have a more complicated inequality, to get the variable x on its own so it looks something like this that I could create a number line from. The problem is there is an extra rule that I have to do. So when we're solving an inequality, we really do it the exact same way that we do an equation. Your whole goal is isolate the variable. Okay. But we want to see, do the same tools end up working? So I'm going to go ahead, I'm going to add, subtract, multiply, and divide by a bunch of different numbers to see, do I keep my same underlying meaning? So I'm going to start in all of these with true statements to see what happens. So if I have 10 is less than 20, that's true. I'm going to go ahead and add 8 to both sides. And in doing so, that tells me 18 is less than 28, which is still going to be true. So this is good. Adding a positive number did nothing. If I go ahead and subtract 8 from both sides, we're starting still with the same statement we know is true. 10 minus 8 is 2. 20 minus 8 is going to be 12. So this is still true. So adding or subtracting a positive number did nothing. Now let's go ahead and do a negative number. Let's add -2 to both sides. And in doing so, 10 plus -2 is really 10 minus 2. That gives us 8. 20 plus negative 2 is 18. So it is still true, which is good. If I subtract a negative number, so let's subtract negative 2 from both sides. 10 minus negative 2, remember minus minus turns into a plus. So this really gives us 12 is less than 22. So 20 plus 2 is 22. So still something that is true. Okay. So adding or subtracting a number, still going to be a tool that doesn't change the underlying meaning. Now let's try multiplication and division. Starting with the same statement, let's multiply and divide both sides by 5. 10 times 5 will give us 50. 20 times 5 will give us 100. And indeed, this is still going to be true. If I divide both sides by 5, 10 divided by 5 is 2. 20 divided by 5 is 4. Still going to be true. So adding, subtracting, multiplying, dividing, so far hasn't seemed like it's done anything different. Now, however, let's try these negative values. So we have 10 is less than 20. We're going to go ahead and multiply both sides by negative 5. So we're going to take this side, times it by negative 5. This side, times it by negative 5. That leaves me with negative 50 and negative 100. Now the problem is, if you were to think about graphing these on a number line to talk about which one's bigger, here's 0. You're going out and counting by 1 each time. Negative 50 would be here. And then you keep going. Negative 100 would be over here. So technically the bigger one is negative 50. So what actually has to happen in order for this to stay true, I've got to switch the inequality sign to the larger quantity. And it might be a little bit easier to see with this one if I divide both sides by negative 5. 10 divided by negative 5 is negative 2. 20 divided by negative 5 is negative 4. And this one's a little bit easier to see with a number line. Here's 0, negative 1, negative 2, negative 3, negative 4. Okay. The bigger one is the one further to the right. So negative 2, wrong one I circled, is the bigger quantity. So again, I've got to change that inequality sign to make this a true statement. So actually the same rules are going to apply. You can always add, subtract, multiply, or divide by any non-zero number. But when you multiply or divide by a negative number, you must flip the inequality sign. Because in both of these cases, to end up with something that is a true statement, I had to switch which one it was facing towards. Because again, remember, the alligator always wants the bigger of the meals. So let's try a ton of examples. We're going to solve the inequality, and then we're going to graph the solution on the number line. So your whole goal is still the same: solve for x. Get x by itself, and just keep this extra rule in mind that if you multiply or divide, you've got to flip the sign. So in this first example, if I want to get x by itself, I first need to get rid of this plus 5. So I'm going to go ahead and subtract it on both sides. And that way these two cancel. That leaves me with 5x. And then 20 minus 5 is going to give me 15. Now to get x on its own, we go ahead and divide. And I don't need to worry about flipping anything because I'm dividing by a positive number. So my sign is not going to change, and this gives me x is less than or equal to 3. So this is our solution. Now I want to go ahead and graph it on a number line. So 3 is my important number, so I'm going to put that right in the middle. And then I'm just going to count up and down 1. So we want to go ahead and put a circle at 3 because it's less than or equal to. That means I can fill in my circle at 3. And again, I point towards the biggest thing. So the biggest thing is 3, which means I'm going to go ahead and shade to the left-hand side because I can take all values up to or equal to 3. And what you can do to check that this works is you can pick one of the values on each side and see, does it give you a true statement? So if I try to plug in 2, 2 is less than or equal to 3 is true. But if I plug in 4, 4 is less than or equal to 3 is false. So that also tells me which side is going to be shaded. Moving on to B, we got negative 4y plus 14 is less than or equal to 18. So same idea, get the y by itself. So that means I got to get rid of this 14 first, and subtraction will undo that. That leaves me with negative 4y, and then 18 minus 14 is going to be 4. And now I got one last step to get y on its own. I need to get rid of that minus sign too, which means I need to divide by negative 4. And because I'm dividing by a negative number, I need to flip the sign. So that leaves me with y, because those two are gone. On the right, 4 divided by negative 4 is negative 1. And I need to flip the inequality. So it needs to now face the opposite direction. So this is a step you have to be really careful about. Double check when you multiply or divide. So that is our solution, but now we want to graph it on a number line. So negative 1 is going to be my center point, and again, I'm going to go up 2 and down 2. If I add 1, that's 0. Add another 1, it's 1. Subtract 1, just to get a few points. So I'm going to put a circle at my key point. And because I have that bar underneath, that tells me I can fill in my original, or I can fill in my circle. And now, because my arrow is pointing towards y, that means y is my bigger quantity, negative 1 is the smallest. This tells me to go ahead and shade this side. But again, you can plug in numbers to check that it works. 0 is greater than or equal to negative 1 is a true statement. Negative 2 is greater than or equal to 1 is not true. Okay. The other thing you can also do is you can actually plug it back into your original equation. Because if you forgot to catch that flipping, you would see that you shaded in the wrong half. You'll still end up with the same solution, but you just picked the opposite thing. So here, if I do plug in 0 for y back into the original, it should work. So we're going to plug y equals 0, and that will give us negative 4 times 0 plus 14 is less than or equal to 18. Negative 4 times 0 is 0. 0 plus 14 is less than or equal to 18. And indeed, 14 is less than or equal to 18. So I did shade the right side. What would happen is if you didn't flip, you kept the inequality the same, you would see that in this case, negative 1 is my biggest thing. That would indicate to me to shade over here. But if I plug in 0, it works. Well, that means I did the opposite side. So this is where I can catch that I made that mistake and forgot to change my sign flip. So let's try just a couple more. For C, we've got x divided by negative 3 is less than negative 5. So in order to get rid of division, we got to go ahead and multiply, which means we need to do the same thing over here. And because I'm multiplying by a negative value, I need to flip that sign. So at least over here, I'm just left with x because these two are gone. And then if you do -5 times -3, it's positive 15. And now I want to switch the way my inequality was. So that is our solution, but let's go ahead and draw a number line. Add 1 and then subtract 1 a few times. That will be positive 14 and positive 13. So 15 is our key. I cannot fill it in because I don't have that equal to underneath. And this tells me I can take values that are bigger than 15 because it's pointing away. So immediately that tells me I'm going to shade to the right-hand side, okay? And again, you can check in the original to see if this works. So if I plug in 16, it should work. If you do 16 divided by -3, it should be less than -5. And you do have to plug this into your calculator. 16 divided by -3 is -5.33, and it just keeps repeating. So we usually use a bar to indicate that. -5.333 is indeed less than -5. To just show you, -5 is here, -6 is here, -4 is here, 5.3 is here. In comparison to 5 is the bigger quantity. Okay. So let's try one more, and then again, get lots and lots and lots of practice with this. In this case, we've got 23 is less than or equal to y divided by 3 minus 10. I've got to isolate my variable. So again, before I worry about taking care of this division, let's get rid of the stuff that's attached to it. So let's go ahead and add 10 because -10 and positive 10 cancel out. 23 plus 10 is going to give us 33. And then we have y divided by 3 on the right-hand side. Then to undo this division, we go ahead and multiply both sides by 3 to make them cancel. 3 times 33 is 99. And we're just left with y. I don't have to worry about flipping my inequality sign because I was working with positive numbers when I was multiplying. So that is our solution. But we want to graph it. So 99 is our key number. Add 100, add 1, 101. Subtract 1 a few times. 99 is the key. And because I have less than or equal, I can fill it in. And then my inequality is telling me that y is bigger than or equal to 99. So I can take all values that are bigger than it. So it means I'm going to shade to the right. So again, just to check, you can check right here. But because we did multiply or divide, let's go ahead and plug it back into the starting statement. So I'm going to plug in 100, and it should give me a true statement. So 23 should be less than or equal to 100 over 3 minus 10. Unfortunately, it's not a nice number, but that's okay. 100 divided by 3 is about 33.33333 and a ton of threes over and over and over. And then we're going to subtract 10. And if you do that subtraction in your calculator, you're going to see it's about 23.33333. And so 23 is definitely less than 23.333. So this right-hand side is the one we want shaded. Okay. So take your time with these. Be extra careful of this step, that if you multiply or divide by a negative sign, you have to flip the sign because it needs to go towards the opposite quantity.